So we'll use some other properties to find some exact expressions. And remember, once again, in this class, we're looking for exact answers. We are not looking for decimal representations. So let's do a few of these. 59. They're asking us for the sine of negative 60 degrees. Now, we know sine is an odd function, right? The definition of an odd function says f of negative theta is equal to negative f of theta. So we're going to use that. So that's the same thing as negative sine of 60 degrees. And we know the sine of 60 degrees if we go back to our unit circle over here. 60 degrees is going to have a sine of square root of 3 over 2. So this is going to be negative square root of 3 over 2. Let's do 66. 66 is looking at the cosine of negative 270. Okay, remember cosine is an even function. So what that means is f of negative theta is equal to f of theta. So that would be the same as the cosine of positive 270 degrees. Now going back to our unit circle. 270 would be down here. And that cosine is going to be 0. So you may want to take a minute, try a couple more. Try this one and this one. Pause the video, come back, check your answer. So 71, we're looking at the tangent of negative pi. Tangent is odd, so that's the same thing as the negative tangent of pi. Going back to our unit circle. Pi here, tangent is y divided by x. So we're going to have a negative 0 over negative 1, which is just going to be a 0. And then in 75, we're looking at the secant of negative pi over 6. That's the same thing as negative secant of pi over 6. And secant, same thing as cosine. Oh, just kidding. Hold on. Secant, remember, that's an even function. So secant of negative pi over 6 is the same thing as secant of positive pi over 6, which is 1 over cosine of pi over 6. And the cosine of pi over 6 is square root of 3 over 2. That's 2 over square root of 3, or 2 square root of 3 over 3, if we rationalize. And I just want to look at maybe just a couple more. So you write in this space. What if we were looking for something like simplify? Sine squared 40 plus cosine squared 40. And then maybe secant squared 18 minus tangent squared 18. And then this last one over negative 20 over cosine of 380 plus tangent 200. Okay, so what if we want to do these? Let's start with that first one. Sine squared 40 degrees plus cosine squared 40 degrees. That one goes back to our 5-star general, right? And what this is saying is it doesn't matter what that angle is, as long as they're the same. Sine squared of some angle plus cosine squared of the same angle has to be equal to 1. So this guy's going to have to be equal to 1. Let's look at that second one. We got secant squared minus tangent squared. So that's really similar to that derivation of this, right? We had tangent squared theta plus 1 is equal to secant squared theta. If we were to tweak this a little bit, let's move that tangent squared to the other side. We have secant squared of theta minus tangent squared of theta. And what this is saying is as long as I take the secant squared of some angle minus tangent squared of the same angle, that's going to be equal to 1. So we can reweight that here, and we're going to get a 1 there. So now let's look at that last one. And this is going to use some period properties as well. So first off, we know that sine is an odd function, right? Which means I could rewrite this as negative sine of 20 degrees. So now I got to think about cosine of 380. So if I look at cosine of 380, okay, cosine of 380, that's going around a little bit more than a revolution. Now, because this is 360, and I'm going to go another 20. So the cosine of 380 would be the same thing as a cosine of 20. So I just got to think about this here. What do we know about the tangent? We know that the tangent has a period of pi, and pi is the same thing as 180 degrees. So what that means, if I think about my unit circle, is that the tangent of 200, right? Tangent of 200, which would be somewhere around here, is going to be equal to the same thing as the tangent of 20. And they're going to have that same value. If you think about the unit circle, let's do one that's on the unit circle. 30 and then 210. So a tangent of 210 would be y divided by x, right? It's going to be a positive. If I were to subtract 180 from this, because that's the period, I would get the tangent of 30. You see how it's going to be the same value, y divided by x, still going to be a positive? That period for the tangent function is 180 degrees or pi, so we can use that to simplify this. Now everything's in terms of the same angle, and now this guy becomes really easy. Sine over cosine is tangent. Negative tangent of 20 plus tangent of 20, I'm adding, well, that's going to reduce to 0, right? So there's our final answer. So that's using some of those properties that we've talked about to simplify some of these trig functions a little bit, to make them a little bit easier.